The essence of Think Dynamic is to push beyond the status quo and redefine what's possible in technology. I'm Yolanda from North Anglia Chinese International School, and I'm glad today to share with you my groundbreaking idea, which can take us, the human civilization, a significant step towards achieving universal health coverage and access to quality healthcare. Single chip world shift. I came with this idea in my English entrepreneurship project. My father is a manager of a smartphone chipset company. His expertise in integrated circuit field has inspired me to explore this innovative idea of combining social healthcare problems with chipsets. Therefore, when we started our entrepreneurship project, I came up with this project film idea, Sickle Cell Gene Edit Chip, which you could also call as an SCD chip. Sickle cell disease is the 12th leading cause of mortality rate globally, a severe genetic disorder that turns red blood cells rigid, causing an estimated 376,000 deaths annually worldwide. Gene Edit Company aimed to harness the power of cutting-edge technology to create a permanent transformative solution rather than a temporary traditional therapy. The collaboration with my project teammates has led to the incorporation of a revolutionary technology founded by Dr. Jennifer Doudna, CRISPR-Cas9. CRISPR refers to clustered, regularly interspaced short palindrome repeats. The two main components in CRISPR-Cas9 are, firstly, the guide RNA. This part is used to protect the chip when moisture. Secondly, the Cas9 protein, which is used for coding the root cause DNA. Imagine our DNA as a piece of text. If we suspect that there is a grammar issue, we could use a highlight function to correct the incorrect phrase. Therefore, the guide RNA is defined as the find function in the human DNA. Next, we refine the grammar issue. Therefore, the Cas9 protein is defined as the editing function in the human DNA. The chip is inserted directly into the red bone marrow. Hence, the combination of chipsets with CRISPR technology will enhance a very specific and targeting issue in homology-directed repair. Now, I would like to move on to the 5 years of the SCD chip. Firstly, the delivery system. This is the part where the chip uses vectors, a modified virus, to transport the guide RNA and the Cas9 protein to create a double-strand break in the human DNA, which is also where the CRISPR technology is mostly used. Secondly, the repair system. Once the Cas9 protein cuts a viral gene, the repair template guides the altered DNA through the homology-directed repair, a repairing mechanism that uses a viral vectors to fix the double-strand break. Finally, it incorporates the correct homology sequence and restores the normal red blood cell function. Thirdly, the cell battery. I consider the battery as a pivotal part from the chipset, but it's also where the issues are mostly found due to the chemical reactions that could happen in the red blood gene. Therefore, we choose to use biocompatible materials in order to minimize the need for invasive battery replacements. Next, our monitor system. This part connects to the Go Gene app, allowing patients to upload real-time health tracking data using the safe Bluetooth technology. Last but not least, the biocompatible parent link coating. This coating is used to protect the chip from moisture and chemical reactions that we have already mentioned above, ensuring the chip's longevity and effectiveness. Gene Edit's purpose of function design is the 3 S's, which stand for safety, specificity, and sustainability. I consider safety as a foremost component of running the chipset. While the product is extremely innovative, it is built upon the mature gene editing technology that could have the potential of transforming lifetimes. Specificity, which has already been reflected by the 5 layers of the chipset. The chip is a sophisticated and motivated solution designed to tackle the sickle cell disease at its core, and will be diversified considering the varied phenomenon the patients are facing. Lastly, sustainability, which is evidenced upon our partnership with the 2030 Sustainable Development Goal 3, to ensure healthy lives and promote well-being for all ages. Gene Edit Corp believes that the advocation of SCD chip is not only a treatment for a certain gene issue, but also a long-term goal for human civilization to contribute to a more equitable and impartial world where access to quality healthcare could be available for global citizens all around the world. Now, I want to take a moment to reflect on why am I here today. Behind every statistic and every medical term are real people, individuals and families affected by sickle cell disease. The pain, the uncertainty, and the struggle for a better life are experiences that resonate deeply with us all. At the end of my speech, you may think, oh God, a 13-year-old girl telling me how to promote a gene-edited chip? You must be joking. I'll tell you then. Dare to dream, and we can change lives in ways we have only dreamed of. And this, the sickle cell gene-edited chip, is undoubtedly the essence of Think Dynamic. Thank you.